and your project. That would be awesome.
So, good morning, everyone. My name is Akanksha, and I'm thrilled to present my Capstone project today. So, my topic is AI powered threat hunting, a machine learning based anomaly detection in the network logs. So, in today's landscape, securing modern networks require more than just traditional defenses. We need to move from reactive measures to proactive threat hunting. So, before we go into any technical details, a bit about my background. I stand at a unique intersection of disciplines. My journey began as a medical lab scientist where I learned the critical importance of diagnostic accuracy and the impact of timely results in the patient's lives. I extended my skill set into data science, learning how to extract meaningful insights from complex data sets. Now, as a cybersecurity student, I'm bringing these worlds together. My vision is to apply rigorous scientific data analysis to protect the critical infrastructure that supports healthcare and other essential services. So, why is this project necessary? Today, we are facing a storm in network security. First, data overload. Modern networks generate traffic at a velocity and volume that simply exceeds human capacity to review. Second is legacy failures. Our traditional signature based tools are failing us. They catch known threats but are blind to new subtle zero-day attacks. Third is alert failure. Security operations centers are overwhelmed and analysts are buried under mountains of false positives, leading to burnout and missed alerts. Finally, we have visibility gap. We lack real-time visibility into the behavioral anomalies. By the time we react, the attacker has often been inside the network for weeks. So we need to close this gap. We need to move from reactive measures to proactive threat hunting. To make this concrete, let's look at a case of MedLab Diagnostic Company. MedLab is a crucial 24/7 pathology service, processing over 20,000 tests a day. Their uptime isn't just about profit, it's about patients' health and safety. They suffered a stealthy attack. An advanced persistent threat group compromised a single workstation using stolen credentials. Because the attacker used valid logins and standard administrative tools, um, and used tactics such as living off the land, um, it was really they moved laterally through the network for weeks without triggering any signature based alarm. The result, when the attack finally detonated, it caused 9 hours of total downtime. Over 450 urgent patient results were delayed. This incident highlights the critical need for a system that could have flagged the unusual behavior of that specific workstation immediately, regardless of the valid credentials. This brings me to my solution, a dual model AI threat hunting engine. I designed it to solve the needle in the haystack problem by using two distinct but complementary systems that can automatically analyze large volumes of traffic in real time, detect both known and unknown threats, surface risk flows and suspicious hosts, provide actionable insights, and reduce the noise, false positives, and investigation time. So, coming to the training phase of the model, first we have random forest, which I call the guard. This is a supervised learning model which is trained on known attack patterns. So it is highly precise at identifying threats we already know about, like denial of service or some special exploits. Second, we have isolation forest, which I call the hunter. This is an unsupervised model, so it doesn't look for any specific attacks. Instead, it learns what normal traffic looks like and then flags anything that deviates from it. This allows it to catch the unknowns, the zero-day attacks, and anomalies that signature-based tools might miss. Now, let's look at a short demo video to walk you through the back-end logic and training process. Let me know if you guys can hear the what? Sorry.
Welcome to the back-end engineering of the project. To build a threat hunting engine capable of detecting modern cyber attacks, the first requirement was to find a dataset. For this project, I selected the UNSW NB15 dataset. Unlike the older dataset, this was generated in a CyberRange lab to stimulate realistic modern network traffic. It contained a mix of normal activities as well as 9 different types of attacks from fuzzers, analysis, backdoors, DOS, exploits, generic, reconnaissance, shellcodes, and worms. So we first started by downloading the pre-partitioned dataset, which was configured as training and testing set. Then we imported this dataset into our Jupyter notebook and analyzed it using Python. As you can see from the shape command, we are working with a massive dataset of network flow. Using the head and the tail command, we validated the structure. So each row represents a network connection with 45 distinct features ranging from basic protocols to deep inspection matrix. So before modeling, I wanted to know more about the data set. So we did some, so to understand the statistical properties, I used the info command to check the data types and then if there were any null values that needed to be imputed. Next, we checked the labels. So the 0 represents the normal traffic and 1 represents the attack traffic. And we see that our dataset is roughly balanced, and this is really crucial as it prevents the model from being like biased towards the majority class. Then we also looked at the distribution of the different attacks we have in the dataset. After that, we moved on to visualizing the data in different forms. So first is the correlation matrix. This is really, really important as we can see the correlation between the different features. And if they're highly correlated, we can just take them out because they won't be teaching our model anything different or new. So here you can see a box plot for source packets, and the visualization confirms a really distinct behavioral difference. So the normal traffic is tightly clustered, it's consistent and predictable. However, there are massive outliers in the attack traffic, sometimes tens of thousands of packets from a single source. And this pattern is pretty consistent with the denial of service attack or some automated scanning tool. This visual proof gave me confidence, along with the other features that we visualized, that the machine learning model would be able to distinguish between the attack and the normal traffic. So we went on further. to prepare this data for machine learning. So for this, we had to engineer the data for the models. First, I started by combining the test and the training dataset to ensure consistent processing. Then I removed the ID sec column because it was just for identification and it did not carry like any security value to it. Next, the machine learning models require numbers and not text. So I applied one-hot encoding to the categorical features like protocol, service, and state. This converted the text labels like TCP or HTTP values into a binary vector the model can understand. After this, we split it back into its original form, testing and training data. And also here we applied a scaling feature. So we applied the standard scaling as it normalizes the data so that the features with huge numbers like bytes do not overpower features with smaller numbers or values like TTL. So this step is mathematically required for our anomaly detection model, which is the isolation forest. So now we enter into the phase, the training phase, where I implemented like a dual model architecture. The first model here we see is the random forest classifier, which is a supervised model. So we chose this because it handles this tabular security data really well. It is robust to noise and avoids overfitting. And it also handles the non-linear relationships between features really well as well. So we trained the data and then we gave it the test data set to predict. And using the evaluation matrix, we found that the accuracy of this model was 90%. And more importantly, the precision of detecting the attacks was 0.99%. This meant that when a model alerts the SOC that an attack is happening, it is almost certainly correct. And it successfully filters out the known attacks like the denial of service and generic exploits with very few false positives that you can see in the confusion matrix here. So moving on, we also trained another model that is the isolation forest. And the previous model, random forest, can only detect what it has seen before. But to catch the zero-day exploits, I used this model, the isolation forest. So this is an unsupervised anomaly detector. Unlike random forest, I did not feed it with any labels during the training. And instead, what it does is it analyzes the geometry of the data to learn what normal looks like, and then isolates data points that are statistically distant. So when we evaluated the isolation forest, we saw that the accuracy was really low, around 32%. But this is totally misleading because in anomaly detection, we're not looking for accuracy, we're looking for discovery. Here in the confusion matrix, you see that it successfully flagged 35,775 attack flows as anomalies. This represents the unknown of unknowns, the behavior that are so unusual they warrant investigation, even if they do not match a known signature. It acts as a threat hunting companion to the supervised model. To summarize, we cleaned and encoded the dataset. We trained the random forest to act as a high precision filter for known attacks, and then we deployed an isolation forest to hunt for novel anomalies. This backend logic is what powers the real time dashboard, turning these raw statistical probabilities into alerts you can see on the screen. Thank you. Welcome to the back end.
So now I would like to introduce to you the threat hunt, a dashboard that I built as a prototype using Gemini to visualize the data in real time. So here you can see the main monitoring screen. Sorry, it's reloading. Yeah. So on the top, we have the real time snapshot of what the model is analyzing. So first we have the analyzed flows that is telling us what that is showing us like the network flows that are being processed in the last 10 minutes. Then we have the detected flows or threats that is being detected using the supervised model that we used, that is the random forest. Then we have the detected anomalies, which detects the anomalies in the network packets using the isolation forest model. We also have the suspicious host um, output, like that shows us that the system is automatically identifying hosts that are generating the highest volume of alerts, helping analysts to prioritize their investigations. Then here we have the anomaly score heat map, and each bar is a flow and the color reflects the severity. So it gives the analyst an immediate sense of when the abnormal activity started to spike. On the right, we have a list of suspicious hosts as well, which lets us identify the potentially compromised systems in our network. Then, moving on, we also see the targeted services, and this shows which services are being targeted or generating the most anomalies. Moving on, I would into the flow investigation. So here we can see in-depth analysis of what of each packet and the time, source, and destination IP, the protocol, the byte size, and the category into which our model is categorizing them, like fuzzers or something, and then we can see a detailed view of what the model is doing as well. Then the core value in this is actionability. We are turning malicious millions of raw packets into clear blocked or flagged decisions, which we can see in the action list. And at any point, if there's any problem, the analyst can export the data using the CSV files into their Excel and make a report out of it as well. So going back, we still have this project is still in the beginning phase. So there are some exciting directions for future development. So first is automated responses. So imagine a system detecting an infected host and automatically isolating it via API calls to the firewall. Then we would also like to add explainable AI, where the system shouldn't just say that this is bad, but explain the reason for its suspicion. And then we would like, then is the federated learning, where it would allow us to train our model on data from multiple hospitals to improve the detection without ever sharing any sensitive patient privacy data. So Of course, I'm not the first one to think of AI in cybersecurity, but there's a specific gap in the market. So, CrowdStrike is a leader in endpoint protection, but it's expensive and requires installing agents on every device. Then we have Darktrace, which offers an excellent immune system approach, but it often is a black box because it's hard for analysts to understand why a decision is being made. Then Vectra AI is great for network detection, but it's geared towards large enterprises with massive budgets. But our niche is a lightweight, transparent, and hybrid model. It is optimized for specific sectors like healthcare, where installing agents on every medical device isn't feasible. So, to conclude, the project successfully demonstrated that a dual AI project approach can significantly enhance threat hunting capabilities. We built a prototype that detects 90% of known attacks with high precision and successfully flags 30% of zero-day anomalies that traditional tools might miss. The real world impact is profound. For an organization like MedLab, this means moving from reactive to proactive defense. It means reducing the dwell time of an attack from weeks to minutes, and protecting patient data and ensuring that critical services remain online. So, thank you for your time, and I'm happy to answer any of your questions.
Um, and Anksha, I want to swear out loud your thing is so good, but I'm not going to remain professional. You're very quiet in class, but you might be one of the best ML people that I've seen come through ever. For those that don't quite understand how brilliant what you've just seen is, and like 10 out of 10 brilliant, maybe even more. I showed my AI as I was going, and my AI was speechless as well.
Okay.
You use the method that preserves privacy for patient data that probably I'm the only one in the room that understands. Maybe Josh might understand it as well. She's using a vector-driven analysis approach. So at no point do you need to actually feed into it the patient data because
That's incredible, right?
yeah.
Like
So
to completely bypass the privacy issue
yep.
is phenomenal. Like this is revolutionary for hospitals.
Mhm.
Yep. Like Josh sees it as well. So for those that don't see it, what a vector database is storing, it's storing the shape of things. It's not storing Luke is blood type A or Ananksha is blood type B, etc. It's storing the shape of it, which preserves privacy. This is beyond brilliant. You need to go and get a job with Mandiant in Sydney. Mandiant, for those that don't know, is Google's cybersecurity company, but they also happen to have a headquarters in Sydney. I would strongly suggest you knock on their door, even if they don't have a job, and show them what you've done. Either them or eHealth New South Wales. The other two places, and again, I don't have any questions, I just more have a comment, would be ResMed or Cochlear if you want to stay in the actual medical space. So Mandiant would hire a person like you with what you've done without even having a job role there. And I hope you understand that, Ashanka. If you can get it in front of their eyes and make them see it, they
Yep.
will create a job for you. They will not need a vacancy. Wow. That's all I can say.
Kendra, don't let this just fall to the wayside. You really, really need to do something with this.
Yeah.
And use this as your little advantage, not little advantage, for a big advantage when you go into any interviews.
Yes.
Even if for some reason you decide that you don't want to do this, use it in your interview process because it's gonna get you somewhere. This is incredible.
If you can sit in front of a data scientist or two from Health New South Wales or eHealth New South Wales, they will understand it. Michelle, the problem's going to be the average HR person or the average person is not going to get what Ashanka just produced. This is in the top 3 best technical projects I've ever seen. Like
There
not even
is
the IOD. This
Thank
is, I've
you.
seen thousands of students at university, Ashanka, like tens of thousands that I've marked. I'm going to say it, fuck, yours is one of the best I've ever seen. And I understood and totally followed along with what you did. And
Mhm.
I'm not speechless, clearly. I'm shocked. Like I'm shocked in a really positive way. Like, damn. Like, wow.
There's also a bunch of cybersecurity incubators that you might think of showing this project to if you wanted to spearhead it yourself.
Mhm.
Yeah.
I think that with the amount of investment going into cybersecurity innovation, this is definitely a viable product that would be considered by a large number of incubators.
Okay.
Shankar, do you want to make this a product as like, do you want to deliver this as something to sell?
I do, yes.
Okay.
I would
Um,
like some like support as well because I can't do everything on my own because I don't understand the back end of how to integrate it together and
yeah.
make it like a software or something to sell, you know.
Yeah.
Mm.
There's two thoughts about that. Depends on whether you want to sell this, like I'm saying, you could literally walk into a cyber AI driven role at somewhere like Mandy and get paid so much that you don't
Mhm.
worry about running a business. So
Okay.
that you would be looking at jobs with this level in even in Australia at about $250,000 a year.
Okay. Okay.
So that beats selling it, I guess, but at the same time the problem with a person like you, it's the same problem that I had. Sometimes our technical ability outshines the ability for the HR team to understand what it is that we're building. So
Yeah.
if I was you, I would go to as many conferences as I can. I would go to as many meetups as you can, and I would be making sure that you go out there and talk to eHealth New South Wales. Somebody like eHealth New South Wales might even sponsor you to go
Mm-hmm.
to an incubator to develop it more. So where I live here in Brisbane, there's literally a state government run incubator that runs here, and they usually have about 20 to 30 startups, and the state government sponsors them. So they provide them with workspace and things like that. New South Wales government has the equivalent. I'm just not sure what it's called. But if I
Okay.
was you, I would be looking for state government. And the reason why I'm saying state government rather than federal is the pathway is quicker. You still might want to talk to the federal government, but I would absolutely be looking at what incubators are in Sydney. They're called incubators. What incubators are in Sydney that you could potentially join? And they shouldn't require you to invest money to go there. So they will provide you with the office space. They will provide you with the basic needs, and you're
Mhm.
working in an environment with other groups. So it's in walking distance from my house here, the one in Brisbane, and it's really good. It's kind of like a mini Silicon Valley here in Fortitude Valley, where there's about 30 different companies all doing different commercial projects, but they all have the backing of the state government. The state government's not paying the money. The state government is just kind of giving them a hand with here's the facilities, here is the mentor. They'll even give you mentors. Here is the structured environment. But New South Wales eHealth needs what you've just built.
Mhm. Okay.
So I don't know what else to say other than fucking wow.
Yeah.
Thank